we have a Burke online as well. And
Hello.
hi, Burke.
I'm also here.
Hey, excellent. All right, good. You're here. All right. So looks like Adam is also online here. All right. Hi, Adam. So we have everyone on the organizing committee on here. All right, so let's get started. With this meeting, as I said, we basically have three different goals. One is give you guys a summary of what this year was. You all pretty familiar with your own performance. We want to share other people's performance with you, and also announcing the prize, the stands. Then we want to give you, each of you, about 5 minutes to talk about your technology and to, showcase what you have done. And then, we can have a discussion right after your presentation. And in the end, we're going to have a discussion to get your feedback and also try to look ahead to see what we will need to do in the future to get more out of this competition. Okay. All right. So let's see. Joe, can I share my screen or?
You sure can.
I should be able to. Okay. Yep. Let me see. Well, I'm not very familiar with my
you should be able to share. Then the best thing to do is
the share is disabled for me.
It
so
is.
Okay, yeah, it is.
Let's see. I could probably assign that. Hang on.
Yeah.
I will make you the. Actually, it says you. I'll make you the host. See what happens.
Okay. Let me see. Okay.
Any luck?
Well, let me see. It's still disabled, but there are some kind of open system preferences. Maybe I can open system preferences, then they will be able to, with some permissions or some kind of security thing. Well, I guess it's because of my system security, so it may have to do some kind of permission to share. Let me see.
And what did you want to share? Did you want to, if we have trouble, did you want to share the Google presentation?
Yes, Google presentation. Can you do that?
I can do.
Yeah, because thank you. Because it asked me to create the web decks and then come back with this permission thing. So yes, so if you could do that, that would be very good.
All right. How does that look? Okay.
Looks good. Yeah.
Okay.
Yeah. Can you click on the present?
Yes. Yeah.
On the top. Yeah. All right. Very good. Thank you. So now we're just going to get started. So first, we're going to give you very brief summary, and I'm going to talk a little bit more on the service side, and Joe going to talk more on the manufacturing side. And I think the other members of the organizing committee could help us to, in case we miss anything, they can add. And then we're going to go through the teams, and the teams can do a presentation to essentially talk about their technology. Okay. All right. So Joe, can you go to the next page? Thank you. All right. So we have altogether 7 teams, and I think 2 teams participated in both tracks, and I'm not going to read through them. But I think all 7 teams probably are here. So after this talk, after this presentation, we're going to have the member of the teams to talk about their technology. At that time, they can introduce their team members. But we do have teams from all over the world. We have 3 teams, I think, from China. We have 1 team from the United States, 1 from Europe, and 2 from Europe, and 1 from Japan, and I think 1 from University of Auckland, which is New Zealand. So that's basically the distribution of the teams. Joe, please, next page. Right, so we have 5 people basically organized this event. And Burke Carty from WPI, Joe Falco from NIST, Adam Norton from UMass Lowell, and Maximum Rowe from DLR, myself from University of South Florida. Next page, please. So this year's we have organized this competition for several years, and this year the competition has 2 tracks, and we have a service track and the manufacturing track. For this service track, we have we basically pretty much do the same thing as last year. So we ask all the participating teams to make 5 cups of mocha green iced tea to go, and so to make each cup, the teams will need to go through 8 steps, and we assign scores based on the difficulty of the steps, and we also break down the steps with small steps within the steps. So they can gain some points and lose some points by skipping some difficult parts. But that's here you can see the distribution of those scores. So some of those are quite simple. Is just pick and place. Especially the last one is after you have the to-go cup, you just have the robot go and pick it up, put on a defined location. Some of them are not that easy, and the most difficult one we see is in step 5. Essentially, has the robot need to pick up pair of tongs and go to pick 2 ice cubes from ice bucket. So they pick 1 by 1, and we only have 1 team who are able to pick 1 ice cube for 2 or 3 cups, I think. And the rest of the teams wasn't able to pick the ice cubes. And also, sometimes the teams have trouble with the bottle cap because the bottle cap sometimes it is small, and sometimes it's difficult to be very precise. And some of the things we thought could be challenging, well, because of the engineering solution, and also because the task has been around for a couple of years. So the team actually came up with very interesting and good solution. For example, pouring, and they have their own strategies of doing pouring water, and without doing much of real-time control with the feedback. So there was some kind of strategy of doing that, and use teaspoon to scoop green tea powder. Is another example. Engineering solution could work, and many of the teams actually getting good score for that without to do a lot of real-time strategy changing or control. All right, next page, please, Joe.
Okay,
So please, Joe, talk about this. Yeah.
Sure. So before I get going, let me just say a few words of why we designed this competition. So I'm with National Institute of Standards and Technology, which is a government organization in the United States. We are focused primarily on robotics for manufacturing. Um, and we've come with this competition because we've identified the need for robot systems that support the small and medium-sized manufacturers, not only in the U.S. but across the world. Um, in the United States, matter of fact, well over 90% of the manufacturers are small and medium-sized manufacturers, and they right now in the current it's getting better and better, but it's very difficult for them to integrate robotics into their manufacturing operations, which are typically low batch, small batch sizes, and quick changeovers to new products and things of that sort. So we designed this competition around the assembly process and being able to reconfigure your robot system quickly and adapt to different manufacturing schemes with the same robot work cell. Um, so we broke our manufacturing track into two parts, disassembly and assembly. The disassembly subtasks, both subtasks use the same task board. One is disassembling it and the other is assembling it. For the disassembly, we allowed 40 minutes to accomplish 32 operations for a total of 92 points. If you happen to finish all 32 operations under the time, you would also get bonus points for the time remaining. Um, so the way it works is we start the time, and at the time of the start, the board is fixed to the table surface within your work volume, and it's placed randomly. So you need to be able to localize on your task board as well as on the component locations on the task board. And there's many ways you can accomplish this. You can accomplish it with perception, um, and you can accomplish it with CAD data, and also based on the tolerancing, if your perception system, meaning vision, is not adequate to locate the insertion holes and things of that sort, then you need to feel your way into the insertion using force control. And we recommend that everyone try to implement all these different aspects into their solutions. We tried to, although you are allowed to do teach programming, as you can see in step one, you can use expedient teaching methods before you switch to fully autonomous mode. Um, we're looking for autonomy, and we're looking to get away from teaching the robot to do things. Anyway, essentially for the disassembly, the robot disassembles a part from the task board and places the removed part into the associated tray. And you just repeat this for all 32 parts. Scoring is based on this: 2 points for each part removed from the board and cable from the routers. And 1 point for each part placed into the kit tray. So if you drop it, you still get points for removing it from the task board. And again, you get a time bonus based on 100% completion under the allotted time. Now, once you finish the disassembly portion, you can use the remaining time to start your assembly operations. But we do cut you off at 40 minutes to stop disassembling the board and move on to assembly. So the assembly operation, we give you twice the time, 80 minutes. It's more difficult. Same 32 operations for a total of 209 points plus time bonus. Again, that you use the same positioning of the task board. You don't need to relocate it. The same random placement for the disassembly. Robot picks apart from the kit layout. So the parts are, we give you a template, and you place the parts on the template, and you have to pick from the template and place them on the task board. So once the robot, so then you assemble the part. So scoring is based on, the scoring is kind of complicated for this. It requires a judge to look at all the details of the final assembly board, but it's based on 1 point for each part contacting a task board surface before the grasp is released. Or if you happen to drop the part and it lands on the task board, you also get that point. So that's sort of the grasping. You're able to pick the part from the kit and get it over to the task board. The assembly points criteria is based on the following. There's 18 fasteners, M4, M6, and M8, 6 of each, for a total of 54 points. 9 insertion operations for a total of 45 points. Insertion includes pegs. It includes the different shape pegs, square, round, rectangular. It also includes electrical connectors, things of that sort. And then there's 4 plastic printed wire. I'm not sure how to describe them. Just a place for you to insert a wire, a slot. And those are pretty difficult, handling a deformable object such as a wire. So those are each worth 10 points for a total of 40 points. And then the other last operation is putting, again, a deformable object, a belt, onto 2 pulleys, and then tensioning the belt for a total of 42 points. Okay, you.
Thank you. Yes, well, we have show you the rules and the tasks we have designed for both tracks. And we can essentially click on this link and tell you where to really see what the actions are. Right, so we created this robotic grasping and manipulation competition channel, and we uploaded all your highlight videos here. So if you haven't taken a look, you can use the link to go there and take a look. And what we're going to do is we're going to put this slides on the web page so that afterward you can download and you can get the link, then you will be able to go here. So we are not going to go through the videos and show you what the video looks like, but by just looking at this, you get an idea of what the task might be and what are the robot people using and so on. If you want to know the details, please use the link and go there and watch the videos for more details. Thank you, Joe. Let's go back. All right, so next page, please. All right, so as Joe have mentioned, we had this online competition, and we have some of our committee members, also some students we got volunteered to do some of the judge, serve as a judge to basically score the competition. The scoring was through internet, so we basically set up, asked the teams to set up two cameras so that we can observe the whole thing from a global view and from a detailed view, which is focusing on the gripper. Usually for this particular track, we had recruited 2 grad students from Berk's lab, from WPI, and 2 students from my lab basically do the judge. And we also have a Berk and Maximo supervised this competition scoring. So we have 4 teams basically finish the service track. We originally have 5 teams. One of the team just basically gave up. And if you look at the scores, the top 3 are fairly close, and the highest score got 680 points out of 1,000. The top team is CoThink and Jilin University, and the second team is CASIA and the Wenjing College, Yantai University. The team got 675 points, and the third team in the ranking is SIAT, CIBS, robots. This team also get about 600 at 622. So we have a 3-team performance fairly well. Again, the total point possible is 1,000. So we have 3 teams basically got more than 60% of the points, which is quite impressive. It is much better than last year. The last year, I think the top score was barely over 500. And there was only 2 teams was over 500, and this year we have 3 teams over 600. So we have the 4th team, Jax, got 45 points, and well, we will listen to all teams, and after this, going to learn from their experience and also their technology. Joe, please, next page. So I combined all the scores together to just try to give you a bigger picture of what has been achieved, what was not that difficult, what was quite difficult for everyone. So if you look at the first 4 and the last 2, and not all teams got 100%, but at least one team got 100% for those 6 steps. And majority of those steps are pick and play. So if they either pick a bottle, or they pick up a teaspoon, or pick up a bottle cap, or even unscrewing a bottle cap. And so they are fairly, they did this fairly well. And we also, at the beginning of the competition, we asked them to move the items slightly around a certain area, and so that, it's not going to be outside of their workspace, but still have some uncertainty to test their perception system. So we can see at least one of the teams will be able to do this task for 100%. And also, if you look at this, some of them have quite complicated manipulation actions. For example, you have to scoop green tea powder, and also you have to pour water, and you have to do stirring, and put on lid, which has to press down the lid on the to-go cup, and insert straw into to-go cup. Those are not very easy tasks, and I think the majority of the teams has done very well. But the one thing we actually observe from this is a lot of the solutions we found we may have to do real-time control or real-time strategy generation. We were able to get around that with some kind of fixed strategy, but with engineering solution. So we're going to talk about this more at the discussion, but here I just want to mention maybe next year, if we do this again, we probably want to make that to be has more uncertainty over there. So we will force the teams to come up with more systematic solution other than engineering solution. So let's look at the 2 steps. None of the teams were able to finish completely. And I also mentioned this, the ice cube is quite challenging, and because the vision system has trouble to really recognize, to estimate the poses of the ice cubes, because they has a similar texture, and they are stacked together. It's very difficult to separate them and estimate the pose of the ice cubes. And also it's relatively difficult to manipulate tongs. And also put the lid on to-go cup. Well, most of the teams were able to do that sometime, but not very consistently. Some of the teams were able to do that maybe 3 out of 5, but sometimes there's one time the lid was not firmly put on the cap. So that's the reason none of the teams were able to get in 100%, but they got fairly high score. So that's interesting to see, and maybe in the future, some teams will come up with a very robust solution for this. But anyhow, I'm really, really encouraged by this, by the scores and by the results, and I think this basically it's kind of reflected the reason we want to have this competition, because we want to see the progress. And we also want to identify what are the challenges in this daily living environment and the tasks. So I think this is a very good purpose to that. Joe, please, next page.
Okay, these are the results of the manufacturing track. I guess up front, I'll say that some of the teams had some technical difficulties during the competition, which is understandable. There's a lot of difficult components associated with it, especially if you try to implement, all aspects of a solution using force feedback, vision, as well as use of CAD data. You can see that SDU Robotics, this is their first time competing in the IROS manufacturing track. However, they have competed using similar task boards in the World Robot Summit in Japan in 2018, which had a component using the same this task board concept, which additionally had an assembly. Essentially the whole competition for the WRS was geared around an assembly. And there was a task where all the robots attempted to assemble an actual product. But one of the tasks during this competition was to break all those components out into a task board and assemble the task board. And SDU Robotics at the time, 2018, won the assembly portion of that competition. The assembly task, we're putting the whole component together into a product. And they performed very well. They'll talk about their system. They used all the components. There was no teaching during the competition. Everything was just calibration routines, and then using vision, force control, and CAD data. You can see that these guys did really well. They completed all the tasks, 100% on both disassembly and assembly, and also achieved some time bonus. This is the first time this has happened using these task boards during a competition. So their total score reflects this as being relatively high at 427. Cassia Wenjing, they performed well also, though I think their solution was geared towards teaching, and they managed to tackle the difficult problems first, which was doing the belt drive and the wire routing process during the assembly process. So you can see they scored relatively high there. New Dexterity, I'll let them talk, but there were some technical difficulties during the competition. Robotic Materials, who is not here today, just so you know, New Dexterity was first place during IROS 2019 in China, and Robotic Materials was second place in the manufacturing track. Both teams had technical difficulties during this. I can tell you, Robotic Materials, I don't think anyone is present from that team today, so the feedback they gave me was during the IROS 2019 competition, they relied strictly on vision and force control, but they did realize the power of CAD data, so they came up with a solution for this competition. And unfortunately, they had some technical difficulties implementing it during the competition. And we also will hear from JAX today, as well as the Munich School of Robotics uh, and Machine. And they decided not to compete at the last minute, but they do have some good thoughts on solutions, and we'll be working on this problem in the future. I think that's all I have to say. Although what I'll say is for future competitions, we toy with a couple of ideas, and one is to take the route of the World Robot Summit and maybe instead of just using task boards, start to move towards a complete assembly, a working assembly. And one of our new task boards that will be coming out this year is based on wire harnessing. So a little bit of cable routing, but then also insertions for putting connectors onto these wire harnesses and bundling the wire harness together with ties. So possibly we could apply control to the product through the wiring harness that has to be assembled finally into a product. So we're coming closer to a full solution to building a product with robotics using robotic assembly. Okay, thank you.
So we're going to discuss the next three pages after we're going to have all the teams to do the presentation. So after that, so essentially we're going to discuss progresses and problems and also new directions. And I hope everyone will pitch in those discussions. But at this point, anyone want to see anything, any comments? And Burke, Maximo, and Adam, do you have anything to add?
Perhaps from my side, sorry, this is Maximo here. So from my side, perhaps the thing I would highlight is from our side as organizers, that we really appreciate the effort that everyone put into this competition. Running the competition with the conditions that we have right now was really challenging from different levels, from the supply of the task boards, for instance, to verifying the conditions of the teams, to scoring using only video streams. So it was also a challenge for us as organizers. But we really appreciate the effort, and we are very thankful about the response to this competition. We hope that you are, even after this, still enthusiastic about moving forward. Now, well, we are really curious to hear your summary, so your experience and your solutions. That would be really interesting.
That's a very good point. To do this, we had to ask all the teams to really do this setup, inspection, and approval, and also has to do a dry run. And then we did the competition. So I really thank everyone, all the participants, spending the time and to make this happen, because it did require a lot of more effort and the time to get this work. All right, good. Anything else from anyone?
I really want to take the participants and other organizers too. Yeah, I think it went pretty well given the conditions. Thanks, everyone.
Very good, very good.
And hey, thanks to the Nerve Center for distributing our task boards. And if anyone out there is interested in some of the other task boards that have been designed at NIST, Adam is his organization is distributing them for us. We highly recommend that you go through Adam, because you're not going to pay more than it costs you to build them yourself, and it sure does take the logistics work out of putting them together yourself. And because he buys many parts at one time, this drives the price down. So it's a good one-stop shopping to order a task board.
Thanks for that, Joe.
Any questions from the teams or comments? Or we can just go to the team presentation. Then we can start the discussion more.
Hi, you. I guess one thing I'll add, this is Peter here from the Munich
Hi,
School
Peter.
of Robotics.
Yep.
Good to see you guys again.
Good to see you. Yep.
Yeah, I think just, while we're at it, like, awesome job putting this competition together. I think it was a little bit of a last minute decision for the conference, but also the organizers and then even the teams. So I think it was really great to be able to participate in this and also to see us all adapt and still keep moving the ball forward. So really hats off to you guys for keeping this moving and for making it possible to continue to do this great work as a community together from home.
Yeah, thank you for the nice comments. Yes. Yeah, and also thanks to all the participants, right? So even this was pretty short noticed, and I was surprised to see how well the performance was. Yeah. All right. If there's no any other comments, and we should go to the presentations then. So let's see. We probably just can do this in this kind of order of the standing, and also mixing the servers and the manufacturing. So we can have SDU robotics to present first. Then we're going to have the servers track present, and then in this kind of order. So yeah, so SDU, you I think you have your camera on, and do you have something ready?
Yes, we are just going to walk around the setup and then.
Oh, okay. Right. So, Joe, can you remove the PowerPoint so that we have a larger screen so we can see them? Yeah, thank you.
Let's see here. Hang on.
Should we just start?
Just need to remove the. Actually, I can make this better too. Hang on a second.
What more?
There we go. How's that?
Oh, okay.
Actually, if we all turn off our video, we could all see it full size.
Let's see. So we do.
There we go.
Good.
Okay, so we will just walk around the setup and then show what we have. And our setup is built exactly like Joe said, to make some flexible automation that we can quickly adapt to different situations. So we have different parts. So our robots, they have a finger exchange system. So it's a finger exchange system that's pneumatically driven. We have sensors on to see if we have a finger on, and then we have attachable fingertips that we can attach to both of our robots, so they can easily adapt to new tasks. And for each task, we can then 3D print just the fingertip to get it a proper way for the task. So I think this helped us quite a bit because we have alignment in the fingers for each part. Then in a similar way, we have a screwdriver where we can attach different bits. So we have here an array of different bits. We have our screwdriver, and each bit can be attached to that. So that's kind of the mechanical part. So on one of the robots, we have attached a camera. So the camera, we use that to determine the position of the task boards, the mat, and also each of the parts. So that was in the initial calibration procedure. We we kind of estimate this process. So actually, we thought that we were going to use visual servoing for strewn, but it was not necessary, so we didn't get to show that feature. But you can see here behind, we have a third robot, and the third robot has cameras attached, so we can do visual servoing if we have uncertainties. And we especially have uncertainty with screw. The screw is in this bit that's a bit loose on the screw. However, because the screws were magnetic and there were chamfers, we didn't have big issues with not hitting the holes. So we actually removed that part. Okay, but that's also something we're working on to be robust towards misalignments and making it easier to set up the task. So for the visual servoing, it doesn't require accurate calibration. However, the robots are calibrated to tabletop, and we can attach a calibration tool into our finger to make it easy. So actually, we have a quick routine for setting up the calibration. Actually, the day of the competition, we had a breakdown of one of the robots. So at noon here, we changed the robot and recalibrated it and changed the camera. So it's pretty quick to set up this system. And I think this is also something that's important for this particular now. Okay. I think this is what we have about our system. So in summary, we try to make it flexible, adaptable to new tasks.
All right, very good. Thank you very much. And are there any questions, discussions? Okay. Any questions?
This is Joe. I have a question. So how did you guys feel about using CAD data? Was it difficult? What format did you use? Was it difficult to implement? Are there a lot of unknowns when you get new, same design, but, updated CAD data or things of that sort?
So actually, we mostly had the issues with the format of the CAD data. But other than this, so we used for the mat, actually we used the SVG files. So and then did matching, template matching on the SVG file, and only used the actual CAD data for the board. But that's actually worked okay for us. But yeah, I think one of the real challenges of this competition was that everything had to work despite reorientation of all these parts. So we really tried to through our testing to exploit space to generate these different scenarios. So we were kind of okay prepared for changes. However, yeah, there could probably be situations that we did not take into account. So I think this mixing up the parts, this is also a very good exercise.
Thank you.
You could all speak closer to the microphone. It's really hard to hear you.
Me?
Yes.
Okay.
I caught a little bit of that, but I'm also curious. I have another question if you are done. But yeah, so I guess I was curious about the quick teach scenarios you guys used. This is for the manufacturing track, is that correct?
Quick teach.
Yeah, you showed me some jigs in the beginning. How much did you rely on the quick teach versus the vision and runtime?
So we only used that thing for calibration. So we had a tool to be attached to the fingers to calibrate the robots relative to the tabletop, and then we used vision to determine the position of the mat and the task board, and then from there on we relied on the CAD data.
Okay, thanks.
And of course,
All right.
we used then force control to kind of alleviate small discrepancies between the reality and the model.
Good. Well, I have a quick question. So for you, because you finished all the components all the necessary components of the competition, which do you think was the most difficult one for you?
I think we used a lot of time on the belt and the USB cable. I think these were the most difficult ones. So
because they are flexible, or what?
Yeah, because they are flexible, and it was also so now we didn't use vision to determine the position of the USB cable. So we had to all the time have a knowledge of where the cable was, and I think this was one of the difficult parts.
Very good. Very interesting. All right. Good. Thank you very much. And due to the time concern, we have to move on. It's very, very interesting. We can have a more discussion, I think. I think there are something in the chat. Oh, no, there's just previous comments. All right. So thank you very much. So next one, can we have a co-think Jilin University to talk about their approach?
Hi guys, I'm Wei from co-think Jilin University. I would like to play our summary video. Maybe during the video we can mention about the techniques we used for this competition.
Okay,
let me
good.
see if I can open my share function. Okay.
Okay, that looks good.
Are you guys able to see the video?
Yep. So you have 5 minutes.
Yeah, that's roughly 5 minutes, 4 and
Good.
57 seconds. So first we do the preparation, as Professor Swen has told us to do. We move those objects a little bit, so to make the vision. So to deal with the different object sizes, we came up with a strategy to design a composite gripper, which have 5 different travel distances. For larger objects, we use the largest travel distance gripper. For the smallest one, we use the smallest finger. right now we are pouring matcha to the 2 cup. We just adjust the teaspoon a little bit so the tea powder won't fall too much to the table. For opening the cap of the bottle, we twisting the cap like for more than 90 degrees. Then we throw away the cap because our vision can identify the empty bottles. We're showing the speed for the video is like twice fast than the real time, so it's a little bit slower in real time. We have a little trick for putting pick up the teaspoon first. Put it on the table so we get a good position to pick up the handle of the teaspoon. Because at first it won't be able to stir the water very well. For the steps of adding 2 ice cubes into 2 cups, we give up for pick up the ice cube. It's kind of challenging. When it comes to this step 6, for these steps, we were able to put the lid into the 2 cup, but we're not able to secure the lid. So we did manually push the lid, so we lose some points. Straw insertion to the bottom of the 2 cup, we were able to do it successfully. At that time, we're pushing the straw a little bit downward, so to make sure that it was through the bottom of the. So techniques we used for the robot, we have Sawyer robot of 7 degrees of freedom. For the robot, we have a serious elastic actuator. Sorry, the video just end. This is another video for the gazebo video survey, but that's unrelated. So we'll stop the sharing.
All right, very good.
Yeah, techniques. There are other things. Let me think. During the last a few frames of the video, I think it didn't quite play all the content. So other things maybe you can mention is flexible joint. Like Sawyer has very flexible joint. That's one of the advantages for us to grasping and manipulation objects, because each of the joint has torque sensors because of serious elastic actuator. So force and torque can be computed for each the joints, 7 joints, and also the end factor, Sawyer's end factor. Sawyer is also able to do compliance control. You can just drag the arm and do very easy teaching by demonstration programs. Programs we did use a few techniques such as vision with artificial intelligence. We also used behavior tree programming. I think that's all the things I need to talk about. If you guys have any questions, you can mention.
Okay, very good. Thank you.
Yeah.
So you mentioned the benefit of the Sawyer robot. You have a force torque reading from the joints. So in which particular step you think that reading was really, really useful?
I think the steps for putting straw into the tubal cup is kind of useful to detect if it's already in the bottom, since if you push the straw, you know the counter force. Yeah, and
that's a very good point.
Okay, cool.
And other steps, or just that step?
There are steps. Let me look at the steps. Other steps. It should for the ice cube pickup. It should be useful, but we weren't able to successfully successfully pick up the ice cube, because ice cube they have kind of transparent color, and they are lined, like they're stacked on each other. It's kind of hard to use vision to detect them unless we use 3D vision. But in this competition, we didn't use 3D vision. That will benefit a lot. But Sawyer, it can use 3D vision. It can be combined. It's just
very good point.
Yeah.
Yeah. Thank you. Thank you. Any other questions? Okay.
Cool.
All right. Good. All right. Thank you very much. And because of time, we have to move on. So let's see. We have. So I guess the next team is CASIA Winjing College, and they rank number 2 in the manufacturing track, and I think they also rank number 2, if I'm not mistaken, in the service track. Yeah, please, if any member of that team is here, please start presentation. Anyone from CASIA and Winjing College? Nope. All right. So let's move forward. And I think Joe already said the new dexterity research group is not here, right, Joe?
not sure about new dexterity, but I know that University of Colorado is not on.
Oh, okay. So anyone from New Dexterity? No.
This is probably a difficult time for them to join.
Yeah, it's 2 a.m., 2 or 3 a.m. All right. All right. So let's see. Let's go to SIAT CIBS robot.
Hello, Professor Sun and Professor. I see I'm not familiar. Everybody. Now, good morning, and in China is always night.
Yeah.
In fact, I'm the team leader. I'm from the Shenzhen Institute of Technology, Chinese Academy of Science, and then. We majorly in China in the city of Shenzhen, and now it's quite late, over 11 p.m. But another thing is that even I'm the team leader, but in fact I didn't involve too much. So I'm very sad to say that. But there are some team members also joined this. Meetings. So I want to introduce one of my students who is one of the major operator working on this. Maybe he can introduce small technology about our team. So I want my student teaching Lee to introduce our technology. Yes, please begin.
Feel free to turn your video on if you'd like to show us your faces or any of your technology.
Okay.
Okay. Hi, Professor Sun. Oh, can you hear me?
Yes.
Yes.
Oh, yeah. Oh, I'm gonna share the video to you guys since it's cover all the technical details we use in the competition. And can you see the screen?
Yes.
Okay. And first, let me check if you can hear the sound.
Yep. Not the sound of the video, no.
Okay, wait a minute. How about now? Can you hear?
Nope.
Oh, okay. So I will, but you can see the screen, right? So
Yes.
I'm gonna. Okay. I'm give speech with the radio play. And first, it's about our team introduction, and this is our basically from the Intelligent Biometric System Shenzhen Institute of Technology of Academic Sciences, and Professor O is our lab director and the team leader, and here's our equipment. It has Kuka Soya, Kuka Iwa, and Racing Baxter, and Kinoa. Kinoa Jiku2. This is for the completion manipulator we use for. And so basically, last year we also attended this competition, both the logistic track and service track, and this year we did improve a lot. So, and here's about the technique details. And we first about our object recognition. Last year we used the HSV color space segmentation to recognize all the objects. So such implementation lacks robustness and returns in some failure. So, for example, the colored cups and S cubes and the cup lids are very similar. So it's usually we call some faulty segmentation and corrupted shapes. So this year we combine the HSV segmentation with some machine learning method, the SVM, and furthermore we add one more camera to for the computation. Last year we only use a overhead camera, the Connect 2, and this year we add the Wilson 2 T435i at the rest. So this year we improve a lot about the accuracy and the robustness. And for the recognition from the overhead camera, we can get some information about all the objects. And here's some technical details about how we recognize all the objects. The precise basically is divided to 3 parts. First, we recognize the caps since it has the red colors. So we use the color to get the caps first. And second, for the neutrality, we also use the color because it's green color to get its position. And finally, for the cup leads and ice bucket, since they are very similar, so it's and transparent, so it's difficult to recognize all the. So we use SVM classify to distinguish them. And also we consider the noise area to improve the robustness of our system. And here's our training site. We have and here's about the background and noise area. And this about S bucket and the cars. And this is about the lead. So for this time, our accuracy is over 19%, and this is our overall recognition from the overhead camera. And also for this time, our calibration, we do both calibration for the overhead and this is for the rest camera. This camera is mainly used to catch the bottle cap, and put it onto the bottle. And here's a quick comparison about our 2 years competitions. So this year we actually improved in the camera. We added the rest camera reasons, and also we use SVM classify to improve our recognition. And here's about the quick overview about our computing process. Let's see. So first step, we get the critical cap, and for step 2, we get the neutrality. And the third step, this is our mainly improvement compared to the last year. This year we can scrub the bolt cap, and meanwhile, after after pour the water, we can also catch the cup, catch a both cup and put it back to the bottle. So basically, for this step, we obtain all the scores. And step 4 was the water and the 2 glass cup. We add ice cubes. And this is about put the lid. And this is about the straw. And that's all about our technique presentation.
All right, very good.
Okay. Yeah, thank you.
Yeah, also very impressive. Any questions?
I want to add extra comments about our team this time. In fact, we attended the second time, but we know this. Also, we have a similar competition in 2020. We don't notice this. We're only 1 or 2 weeks. We know that. So in fact, we want to have a better hand. I think gripper is very important. So I compare with the other team. They have a higher score with our team. I think they have a very, very powerful and skillful hands. We are just the gripper is the same as the last year, 2009. So some of the tools is very challenging for us to pick it up, such as the spoon and the stool. So because we only know this competition only 2 weeks before the true competition. So we also ask Professor Sun allow us to attend it. So if we have longer time, we'll sure prepare better configuration or better skillful hands instead of the same one, the original one in the robot. This part is we really feel regret. So if the competition continue the next year, we will try to as early as possible to prepare a better hand. This is what I want to add about command. Thank you.
Yeah, that's very good point. Yeah, certainly. Yeah, during the competition, I can see your team manually pick up some of the items and put into the hands, then perform the manipulation fairly well. You are the only team who were able to pick up ice cubes, and so I think that's very impressive. Can any of you share with us how you basically pick up the ice cubes? I think other teams was pretty much just give up because the perception is so challenging.
I think this part is very challenging. Maybe students maybe give more edit. So I don't know about too much. Please, Mr. Lee, you give more about this.
Oh, okay. Hi, Professor. So actually, this part is the most difficult part for this service task. And to be honest, we just we try to add ice cubes. We just got the roughly position of the ice bucket from the overhead camera, and we just try the robot head to catch them.
Okay, so essentially, you're saying that was by luck.
Yeah.
Okay, well, that's good, right? At least you tried, and yeah. So I think I remember you got 2 at 2 different runs, right? So
right. Yes.
Yeah. Okay. All right. Good. Any other questions? Okay. All right. Very good. Thank you very much. And again, it's very impressive. So next, I think we have Jax. So any member from Jax? I see some people here from Jax. Yes, please present your work if you have a presentation or video or any format, or you can just talk about your technology. You have about 5 minutes, or can be a little longer because some teams didn't show up. All right. I think you are muted, so we cannot hear anything, but I can see the video. Again, I cannot hear anything. I can only see the video.
See that he's unmuted, but possibly having connection problems with his audio.
Okay.
We still have no audio. Perhaps you should go on to another team and come back to.
Okay. All right. So we can go to another team, and then we can come back, and maybe Jax will be able to fix the audio at that time. So let's see. We can have Murik. Peter So, are you there?
Hello?
Peter. So yeah, so please go ahead to present your technology, and I think Jax will take some time to fix their audio first. So you can go ahead, please.
Sure. Thank you for the time. So unfortunately, I am not able to share what we have yet, pending some approvals. So I will just speak about it, and I'm happy to answer questions as much as possible. I realize we have a minimal footprint to everyone here since you haven't seen our video yet, and we technically did not really complete full submission. So a little bit of history about our team. So my name is Peter. I'm relatively new at the Munich School of Robotics. I led a team of 4 to put together a competition, just like all of you, at the last minute. Our lab is historically very good in controls, specifically compliant impedance control, closely tied with the Franca Amica robot platform. And so our submission was really focused around using a essentially out-of-the-box Franca Amica setup, so standard robot, gripper, and adding some vision cameras to essentially complete this NIST manufacturing board. You'll have to take me at my word. We were able to do pretty much all the disassembly with minimal effort, using some of our internal tools here at the Institute, which are mostly based on joint torque controls. And we do rely heavily on lead through teach. So a lot of the ideology behind the Franca Amica arm is that we essentially put the robot into a compliant state. We move the robot into position, and then we grab that pose, and we use that to essentially initialize the robot when vision is not available. And my colleague Lars has been working for the better part of 6 years, putting together a pretty cool library that he calls MIOS, which is essentially a motion control library that encapsulates different skills. So this fits really well with the manipulation challenge for this year. Essentially went through and taught of the 4 different sections of the board, kind of involve 4 different types of skills. Insertion was one. Insertion with a screwing action was the other. Doing some sort of pulling or tugging is kind of what we call the other for the belt, and then the USB and Ethernet were also a different form of our insertion tasks. So we hope to share video of our work with you guys shortly. We're still waiting a little bit of approval on the final edits on this, but in terms of that, it was a really great opportunity for our lab to really come together and really compete. This was our first time competing here at the IROS 2020. We are very dedicated to supporting benchmarks like the one presented here, and we look forward to presenting again next year.
All right, very good. Thank you very much. You could, if you have, I think you have some YouTube video. If you want, you can share some of the YouTube video here, because I haven't got a chance to put it on the channel yet. But if you want, you can share the YouTube videos.
Let's see. Yeah, I think, to be honest, the YouTube video is not so much of the robots, but more about me and our team talking about the experience.
Oh, okay.
So I think
similar to what you have just talked
the
about.
best experience for me.
Okay.
There's definitely some
gotcha.
footage of the robots that we can share, but that would not be in that video.
Okay. All right. Thank you. Thank you. All right. Any other questions? Well, I guess they may have more questions after they see the videos. But anyhow, you know, we're going to send us whatever you have afterward, and we're going to post it on the channel, and then you know, people will see what kind of the technology you have used, and what you guys can actually achieve, which is also very, very good. All right, very good. So thank you very much. So let's go to Jax and see if they have the video, the audio fixed.
Can you hear me?
Yes, good.
Okay. So sorry. Can you see the video?
Yes, I can see the screen, see the video, yes.
So it's a basic assist. So I use Yaskawa arm, and it has a force sensor and a compliant joint and 3-fingered hand, and we use RGBD sensor for capturing the image, and we update system for calibration, that touching taskboard for the touching the taskboard, and the position is calibrated, and 3 point attached, and the board is about the positions located, and so we use a compliant joint, and so it reduces match holes for it reduces contact forces. So we have this system has several errors, but it can be worked with errors. But this year we made some mistakes for making the part position. So then we cannot try to the disassembly of the screws. Only big disassembly for some pegs and some gears and yeah. So skipping. And this is assembly. So we use a rotation and grasping again, so it can be grasp the object stably. And we also rotate at the pegging hole. By rotation and compliant joint can pegging holes successfully. And this is not the this is not from competition. That it's a practice. So we use tools, and so we detect the success or not of the screwing. So we try again, and if the screw is inputted, so the rotation speed is up, and yeah. But we make a mistake for making a map of the screw holes, so we cannot try at the competition. Yeah, yeah, that's all.
All right, very good. Thank you.
And
okay.
From service track, Watanabe Sensei, can you explain?
Yes, please. Yeah, you can continue. Go to the service track. Yes.
Or I'll explain using. Okay.
Okay. I will explain about the service track. So can I share the video and can you hear me?
We can hear you.
Sorry. So here is our system. So unfortunately, we did not have a vision recognition system. So we trust the motion generated by motion we generated previously before the competition. So we generated we trust the trajectory. So we generated a trajectory which a little bit robust to the uncertainty, the position and the posture of the object. So even if there are some little bit uncertainty in the position and the posture of the object, we can grasp and manipulate the target object. But also, so unfortunately, we did try only 2 tasks. One is pick up the cup, and the other is fill the green tea with a teaspoon. And here you can see the video, and unfortunately we failed to grasp the teaspoon, so we manually help the gripper so that the gripper can grasp the teaspoon appropriately, like this. And this posture is not good for the studying the posture, so we change the posture like this. And we did stir the water like this. That's all. Thank you very much.
All right, very good. Thank you very much. Yeah, it's quite interesting to see the strategy of your approach of picking up the items. And also, I think in many teams, you have some kind of a regrasping strategy, which is quite interesting. Any questions? All right. Good. Thank you very much. And so in the interest of the time, we have to move on to the last 3 things we want to talk about. Basically, for some of you, it's probably already very late. You feel free to leave, and you can send us emails about your feedbacks. And the things we want to discuss are progresses have been made, and also remaining challenges. You think, some of the things you observe are quite challenging, and also maybe some things we didn't include in the competition, and you think it would be interesting and useful to somehow design some tasks to include those research challenges in the competition. And also future directions. So anything new or anything we should change, feel free to let us know, and we can have a discussion at this moment. Or if it is too late for you, you do not have to stay. You can talk with your teams and send us an email about your input in those 3 topics. Again, those 3 are progresses you felt you have made through the years, and that was expressed and reviewed with the competition. And also remaining challenges can be the challenge you think not already expressed in the competition, or the challenges you think should be expressed, some kind of represented in the competition, so we could change our competition to include those. And maybe more other directions, right? So future directions. So those 3 things, if you want to put some feedback to us, feel free to do that through email. For the people here, we can use the remaining about 20 minutes to go through them and to get some feedback from you, or we can have some kind of discussion on those 3 topics. All right. Okay, good. So let's go through them one by one. So for progresses, I can start. I can see a lot of pick and place tasks was fairly was done fairly well, and especially people have designed very good grippers and to make the grasping easier. So the pick and place, I think, is a very good progress, and also the perception, right? The perception for pick and place is a very good. I can see a very good progress has been made. Anything anyone want to add?
We have some input.
Yep, go ahead.
So we were thinking picking from bins or randomly placed parts so that you actually need vision. We basically solved the whole thing with only very modest amounts of vision, but it would be fun if we couldn't solve it without more interesting types of vision, for example, pose estimation.
Okay, can you elaborate on that a little bit?
Yeah, so bin picking, where you get the parts just thrown into separate bins, one bin per part type, and then you need to pick them from that.
Mm-hmm. Okay, that's interesting.
Yeah, good idea. Yeah.
So it's obviously very it's much harder. It's a big leap. But it's interesting.
So our perception team at NIST is working to develop some measures for bin picking in their laboratory using our task boards. So yeah, we could possibly incorporate something like that in a future competition.
Yep, that's a very good point. Yeah, so we do not have to separate those three topics, right? So feel free to talk about any of those two, any of the three, right? So challenges you think, or you think we should include in the future competitions like this bin picking. Yep. All right. Feel free to speak, right? Anyone?
This is Peter.
Yep.
Yeah, I was curious about how we think about the format of the competition was understandably different for this year's competition. Do you guys in the future envision any restrictions on the robot platforms themselves? I think in this conversation alone, I think there was a difference in performance and opinion based on if you could build a custom gripper versus using a standard like parallel gripper, or like you have like classes of robots by gripping technologies. Just curious to hear the room's thoughts on custom built versus general purpose solutions.
Well, yeah. So as far as the manufacturing track was concerned, we have no limitations on grippers used. So you could use anything from a pneumatic two-fingered gripper to a complex robotic hand. There is also, there's always the cost of a system, but right now that is not a metric in our competitions. It's very difficult to gauge cost. I think that was something that was trying to be done at the World Robot Summit, but I think they gave up on that.
Right. Yeah, that's a very good point. From Sarah's track, we do not limit what kind of gripper the teams can use. There was one limitation is basically they should not switch grippers manually in the middle. And I think for the manufacturing, it was the same, right? Not manually switching grippers, right? So yeah, so you could do automated switching. So I think the purpose was this to really because this is competition, right? So we also have some kind of interest in benchmarking. I think benchmarking would allow the more standard, evaluation. But the competition is more of a comprehensive evaluation of the whole thing. So we encourage people to make innovations in the gripper. So because the problems are difficult, so we want to see innovations from all aspects. But certainly that would, put a lot of burden on the teams. So then you have to have people who be able to do perception, control, and also mechanical designs. Yeah.
Yeah. One of the important things to remember, one of the reasons NIST got involved in these competitions was not necessarily to host competitions, but to help spread the idea of a common set of benchmarks that can be used in the research community. So, we'd like to see everyone take these benchmarks, whether there are task board benchmarks, or we also have some benchmarks for characterizing robotic hands. Take those back to your laboratories and use those more in depth in your research, and report your results using these benchmarks, so that you could compare your research results with the research results of other universities or other organizations. So that's the whole idea behind this, is to promote benchmarking, a common set of benchmarks.
Right. Yeah, for servers, we try to explore and find out really particular tasks which could be used as some kind of benchmarking, right? So some kind of tasks, manipulations, can be considered to be quite challenging at this moment in time. Then get some attention from the community to try to solve it. Yeah. All right. Any other comments or suggestions?
Can I ask a question?
Yeah, please.
So I want to ask, what is the plan for the next year? So the task for the next year is the same as this year, or you will arrange another task, maybe not making a multi team?
Well, that's a very good question. Well, I think at least at this point, I think we will make this to be a little bit more challenging. So we could still doing making mocha green tea, but some of the steps will be modified. And for example, we may want to emphasize more on a clear systematic solution other than engineering solution. For example, scooping and pouring and some other things. So that's basically the direction I'm thinking. But certainly we will need to have a little bit longer discussion with Berg, Maximo, and other people may be interested in participating in organizing for the next year.
Okay, thank you.
Yep. All right. Any other questions and comments? Yeah, feel free to tell us what do you think the direction should go, right? So we only, we have our own research. We understand certain aspects, but we may not fully understand all the aspects. So from your experience, you can suggest us to look into certain directions we may not haven't looked.
Yeah, so from the manufacturing side, we always welcome new ideas for benchmarking. So if you're performing your research and you come up with benchmarks for manufacturing assembly, and something that we don't cover in our current benchmarks, we'd be more than happy to try to incorporate them based on your ideas. So please send me emails with any ideas you might have.
All right, very good. Yeah, so the task is even in the for the making iced green tea, the components of that task were actually recommended by the community. So it's a development of several years. So at the very beginning, we solicited ideas from the community, and they came up about 30 something tasks. And so we basically tried a few of the tasks for the previous years. And the last 2 years, we basically put them together and think making, iced green tea is a kind of a meaningful task that can actually incorporate many of the difficult tasks that people recommended. So if you recommend some other task you think is quite difficult for manipulation, we can somehow to incorporate that in the future competition.
You? Yeah, quick question. So I was trying to get in touch with someone from the technical committee from RAS, IEEE RAS. There is a technical committee on the performance evaluation, benchmarking of robotic and automated systems. Are you guys at all connected to this at all?
Joe, are you connected to that?
I think maybe your colleague is, but no, I guess you and myself have done a lot of this work through the RHGM technical committee, which is on robotic grasping and manipulation.
Right.
But there is quite a bit of overlap.
Yep.
Just curious if there's like a line that we are respecting, or, sounds like their committee name fits pretty well with what we're doing here.
Right,
certainly. Yeah, so we got support from two technical committees, and they are the ones Joe has talked about, and also the mobile manipulation committee, Maximo chair, right? Maximo, are you still chairing that mobile manipulation committee?
Until last year. So now I retired from the committee. But anyways, I wanted to add something here. So indeed, there is a technical committee for benchmarking in general and performance measurement. This is hosted by Fabio Bonsignorio from Italy. But within the other committees, there is a bunch of people working on different benchmarking activities, in particular for manipulation, with Berg and you and maybe Joe as well. We have been hosting a number of workshops at ICRA, at IROS on this topic, and we push forward regularly some special issues. So in Robotics and Automation Letters this year, for instance, we published a number of papers on a special issue regarding benchmarking activities for manipulation, for robotic manipulation. You will find there a bunch of papers that are spearheaded by leaders of the community, and where we explicitly asked them to not only propose a benchmark, but also, validate that benchmark at least in two different setups. The idea behind that is precisely that we have some sort of standardized way to measure different aspects of manipulation, such that you can use that for pushing forward your research. Besides that, we have also one special issue. I think you is the main organizer for a special issue on RAM next year.
Still
Ariel?
letter. Yes, still letter.
Okay, yes. So also about manipulation in general. So we work regularly on these topics. Besides what Joe already said, the activities at NIST, that they also push forward these white papers on different activities to work on standardizing some measurements of performance. So there is a number of activities there, and I think if you have some more specific question, Peter, maybe you can contact us, and maybe we can work around if you're interested on using some benchmark or on being part of some committee or something like that. So feel free to shoot us with an email. We'll be happy to involve you.
Very good point. Yes, just to add up on the special issue, we have this call for a paper for a special issue with RA letter, and the deadline is the end of January. And so the topic on that is directly related to this, right? So it is robotics grasping and manipulation challenges and the progresses. So if you look at the scope of interest, and it's basically mainly about the competitions and the team's performance in the competitions. And also, we also accept papers who particularly address or using any of the competition tasks as a measurement. So that's, we have, I think Berg is also on that special issue. I think Abinis, also on that special issue as organized. I think Joe is also on that special issue. So yeah, so feel free to send us emails if you have any questions.
Great, thank you guys. I'll do that.
Great. All right. So any
Sorry,
other comments? Yeah, please.
Sorry, you just to complete this answer, I'm posting in the chat the link to the call for papers for this special issue.
Thank you. Thank you very much for doing that.
Excuse me, Professor Sun, can I ask another small question?
Yeah, please.
Okay, so I just want to ask, can we still add an additional name to our team? Because one of our team members has made a great contribution to our team, but his name was not put in the list at the beginning. So we hope we can add one more name.
Oh, well, we have this limitation of 5 team members. So can if you haven't reached to 5, then certainly we will add that person. But if you reach to 5
actually,
already,
we have already reached 5.
then you have to find a way, find someone to replace, I would say.
Oh, okay, I know.
Okay. All right. Yeah. So that's back to some other question I have. I think from SDU, I haven't received the full list of the members of your team. So if you can send me that, that would be good. And also for the certificate, we basically going to communicate with IROS to see, because in previous years the certificate has their I think chairs signatures, organizing chair signatures from the IROS. We will figure out how we can get that kind of certificate, or if they have a standard certificate for this kind of thing. So we will let you know shortly after. Okay. All right. Any other thing you want to input or feedback? All right. So if there's no other thing else, and I really thank you very much for participating. And I hope everyone would like to join for the next year. Certainly, we will work together to make this better, and also we will let you know sooner rather than this year. And hopefully by the time of IROS next year, it would not be locked down, or we will find a solution for the pandemic. Then we can have this competition at IROS venue. But we will prepare for everything. Okay.
Actually, I'd like feedback on that too, because it is difficult to travel with a system to IROS. So I'm interested in knowing, not necessarily now, but in the future, if teams are more interested in doing these competitions remotely or in person at a remote venue. So let us know about that.
Yep. So I think that's a very good point. And that saves a lot of trouble of shipping equipment go through custom. And also we can have this more relaxed period of competition. It's not like everyone has to hurry up and be a clear day for everyone to run, and it was usually chaotic. But anyhow, any suggestions or feedbacks on any of the stuff we have discussed today will be very, very useful. All right. Okay. All right. Good. Thank you very much. And it's already been 2 hours, and I really thank the people, especially in the other at the other side of the earth, and stay this late and participate. Really, thank you very much. And yeah, so we will keep in contact, and hopefully we can to discuss this again and have you participating again next year. All right, thank you very much, and thanks Joe for hosting this.
No
Yep.
problem. Thank you.
All right, thank you. Bye-bye.
Bye.